Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Happy Ramadan to all of you. Wishing you a blessed Ramadan that will inspire you with courage, strength, and that will help you to win every challenge of life. Amen. Today lecture is chapter number 1, exercise, and this is my 8th lecture, and I am Mrs. Saira Jamal. We are going to do example 1.8, and this is about how to calculate the number of atoms. Calculating number of atoms in given moles. If moles are given and ask about the number of atoms, so we have very simple formula, that is number of atoms is equal to number of moles into Avogadro's number. So number of moles are given, you can see in this example. Zinc is a silvery metal that is used to galvanize steel to prevent corrosion. Galvanization and corrosion, all you will learn inshallah in chapter number 7. But just at this time, keep this in your mind that zinc color is silver and it is a reactive species, and to prevent it from corrosion or from oxidation and reduction, it is prevented by mixing it with steel. How many atoms are there in 2.5 moles of zinc? Moles are given 2.5 and ask about the number of atoms. How many atoms are there? So first of all, you have to write the data. Number of moles given are 2.5 moles. Number of atoms we have to find out. Avogadro's number, this value you have to learn, which is 6.022 into 10 raised to power 23. Now solution, we will use the formula. Number of atoms is equal to number of moles into Avogadro's number. Number of moles given are 2.5. Avogadro's number is this. By multiplying these two values, we will get the answer 1.5055 into 10 raised to power 4 atoms. Very simple, very easy. And in book the method is different, and this method is the formula method. And mostly the students, they say that this method is easy for them, the formula method. And it's up to you. If the book method is easy for you, you can follow that as well. Okay, both are correct. Question number 2, a thin foil of aluminium is used as a wrapper in food industry. Even you are using aluminium foil at home, and all the candy wrappers, the food cans, the milk, milk, all these are packed in aluminium. So aluminium is used in as a wrapper in food industries. How many atoms are present in a foil that contain 0.2 moles of aluminium? Moles are given again the same. These two parts are totally same, just the difference is in the number of moles. 0.2 moles, again we will follow the same. Moles are given, we have to find out the number of atoms, Avogadro's number, the same formula, just moles are different. So instead of 2.5, here we use 0.2, multiply by Avogadro's number, so we will get the answer. Example 1.9 is calculating number of molecules in given moles of a substance. The calculation of number of atoms and calculation of number of molecules, they are totally same, formula is same, method is same. The only difference is instead of number of atoms, you have to write number of molecules. This is the only difference, and the answer definitely, instead of atoms you will write molecules. Okay, so again you can see moles are given and you have to find out number of molecules. In this case, in example 1.8, we wrote number of atoms, and in this case we have to write number of molecules. Now number of molecules, the same formula, put moles, Avogadro's number, after multiplication you will get the answer. Same is for this example. At high temperature, hydrogen sulfide gas given off by a volcano is oxidized by air to sulfur dioxide. hydrogen sulfide which emit out from volcanoes. It react with the oxygen in sulfur and will form sulfur dioxide. The sulfur dioxide then react with water, rainwater, and form acidic rain. So how many molecules are there in 0.25 moles of sulfur dioxide? Again, the same thing, same formula, just instead of atoms, write number of molecules. Number of moles given are 0.25, Avogadro's number. After multiplication, you will get the answer. Example 1.10, calculating number of moles in the given number of atoms. So in the previous case, they gave us mole and ask about the number of atoms. And in this case, number of atoms are given and we have to find out the number of moles. So this is a little bit different. So you will arrange the formula according to the requirement. You can see the formula was a number of atoms is equal to number of moles into Avogadro's number. But in this case, we have to find this number of moles. So by taking out the number of moles, the formula is now number of atoms divided by Avogadro's number. Just we have to bring this little change and then put the values. Number of atoms given are 3.011 into 10 raised to power 23 titanium atoms. And Avogadro's number, I told you this value you have to learn, and then by dividing these values you will get the answer 0.5 moles. Very easy. Second example is 1.11. Calculating number of moles in the given number of molecules, the same thing. Again, instead of atoms, you have to use the term molecules. Okay, number of molecules. In the previous case, it was number of atoms. The same, taking out number of moles, number of molecules over Avogadro's number by putting the values. Only the difference is here 22. In the previous case, it was 3.011 into 10 power 23, but this time it is 22. And the answer was 0.5, and in this case 0.05 moles due to this 22 value. Self-assessment exercise 1.10, question number 1. Aspirin is a compound that contains carbon, hydrogen, and oxygen, means organic compound. It contains carbon, hydrogen, and oxygen. It is used as a painkiller. You are using Dispirin, you are using aspirin. So these are actually used as in painkillers. An aspirin tablet contain 1.25 into 10 power 30 molecules. How many moles of this compound are present in the tablet? Given values are molecules, means number of molecules are there, and you have to find the number of moles. Same like the previous examples. Same, number of molecules is equal to number of moles into Avogadro number. Number of moles take out, number of molecules over Avogadro number. Number of molecules given, Avogadro's number you have to learn. Answer is 2.075 into 10 power 52 moles. Part B again is totally same. Instead, molecules, write atoms, and then put the values. Here they mention 1 billion. So 1 billion is equal to 1 into 10 raised to power 9. Okay, 9 atoms. And of this is of magnesium. The method cathodic protection. Inshallah, you will learn in chapter number 7. Okay. So by putting the values, but just keep this in your mind for MCQ's point of view, that which metal is used in cathodic protection. So you must know the answer, magnesium. Okay, magnesium is used as in cathodic protection, and also it is used to prevent rusting of ships and underground pipes. Okay, the same thing, but used in ships and underground pipelines and act as a cathodic protection. So by putting the values, you can get the answer 1.6605 into 10 power 31. Coming towards the exercise, the chapter is finished now. Learn the chapter thoroughly, because MCQs, short question answer, they may come from any topic. So now at this level, you have to learn the chapter thoroughly. each and everything you have to learn. Okay, so exercise MCQs, encircle the correct answer. Number one, which of the following list contain only elements? Elements, dear students, I told you that elements may be monoatomic, like the noble gases. Helium, neon, argon, krypton, xenon, radon. I told you these are group number 8 elements, and they exist in atomic form. The rest of the elements, they can exist in molecular form. And I told you how can you identify that this is an element. For this, you will see that if the molecule is made up of similar atoms, like O2, H2, N2, F2, Cl2, they are made up of same atoms, so that will be element. But if the molecule is made up of different atoms, like you can see in this case, water H2O, two hydrogen and one oxygen, so they are not made up of same atom. So this is compound, mixture is totally different, and oxygen is element. So they ask in which of the following lists, A, B, C, D, there are 4 lists, and you need to find out that all the given compounds or all the given substances, they are element. So air is a mixture, water is compound, only oxygen is element. So no, not this list. Second list, hydrogen, oxygen, and brass. Hydrogen, H2, yes, element. Oxygen, O2, yes, element. Brass, but brass is not an element because brass is, you can say, it is a mixture. Brass is a mixture of zinc and copper element. So we call it alloy. No, not brass. Third one, air. Air is a mixture of different gases. Water, I told you, compound. Fire, when we burn any organic compound, that may be coal, petrol, or natural gas, where it gives carbon dioxide, water vapors, heat. So again, mixture and some unburnt carbon particle which produce smoke. Earth, is a mixture of compound, so not this list. And the last list is calcium, Ca element, sulfur, S element, carbon, C element. All these are present in periodic table. And periodic table, I told you, it contains 118 elements in it. So yes, the last list, the list, contain all the substances which are elements. Number two, the diagrams below represent particles in 4 substances. Which box represent the particles in nitrogen? Nitrogen, N2, and element, and it is made up of 2 similar atoms. So if we check the first one, yeah, this is N2, but this monoatomic gases, they are not N2. They may be argon, maybe helium, maybe any noble gas. So not this list. This list again, one ball is small and one ball is big. It may be HCl or hydrogen fluoride. They are compound, they are not elements. All monoatomic gases, no. Nitrogen is diatomic. Yes, this one is 2 similar balls. N2, N2, N2. So D is the correct option. What is the formula mass of copper sulfate pentahydrate? 5H2O means we call it pentahydrate. Penta 5 and hydrate means having water molecules in it. So copper sulfate in the hydrated form, it have 5 water molecules in its crystal structure or in its crystal lattice. Atomic masses are given: copper, sulfur, oxygen, and hydrogen. And you have to find out the formula mass. Formula mass because it is ionic compound and exists in the form of ions. So we will call it formula mass. And I told you the method of finding out the formula mass is same like to find out the molar mass. Atomic mass of copper plus atomic mass of sulfur plus 4 atoms of hydrogen multiply atomic mass of oxygen. 4 atoms of oxygen multiply atomic mass of oxygen plus 5 twos are 10 hydrogen, and atomic mass of one hydrogen is 1. You can also write it 1.008, and then we have 5. This 5 is with hydrogen, and this 5 is with oxygen also. So 5 atoms of oxygen multiply atomic mass of oxygen. By multiplying and dividing all the terms, we will get the answer 249.5. So correct option is 249.5 is the formula mass of hydrated copper sulfate. Number 6, a compound with the chemical formula Na2CX3 has formula mass. The formula mass of this compound is 106 AMU. We have to find out the atomic mass of elements X. This X, you can see X3. So the formula mass or atomic mass of this X3 we have to find out. This is just simple mathematics. Na2CX3 mass given is 106. So how many atoms of sodium are there? 2. And atomic mass of sodium is 23, plus atomic mass of carbon 12, plus we will write 3x because the x we don't know which element is this. We have to find out. Then total molar mass or total formula mass is 106. 23 into 2, 46, 12, 3x, 106. 46 plus 12, 58, plus 3x equal to 106. We have to find out the value of x, so by taking it out, 106, 58 minus 106 minus 58, it will give us 48. Then take out x, 3 will go down, 48 over 3 equal to 16. 16 is the atomic mass of that element. So if you see periodic table, you can see 16 is the atomic mass of oxygen. Okay, so 16 is the correct option. Coming toward the next one, how many moles of molecules are there in 16 grams of oxygen? So as you have to find out the number of moles, so formula is number of moles is equal to mass in grams over molar mass. Mass in gram given are 16 grams, and molar mass of oxygen O2. One oxygen is 16 and there are two oxygens, so into 2 is 32. So 16 over 32 is equal to 0.5 moles. What is the mass of 4 moles of hydrogen gas? Now in this case we have to find out mass. Same formula, take out the mass, number of moles will multiply with molar mass. So mass is equal to moles into molar mass. What are the given moles? Yes, 4 moles. And what is the molar mass of hydrogen? One hydrogen is 1.008, but hydrogen gas means H2, so we will multiply it by 2. It will give us answer 2.016. 2.016 when multiplied by 4 will give us the answer 8.064 grams. So A is the correct option. Number 7. What is the mass of carbon present in 44 grams of carbon dioxide? So carbon dioxide mass, total mass is 44 gram. Mass of carbon we have to find out. Plus there are two oxygen atom, one oxygen is 16. Total is 44. So 16 into 2, 32 equal to 44. Again taking out carbon, 44 minus 32 will give us the answer 12 grams. So mass of carbon is 12 grams. Electronic configuration, this you can see 1s2, 1 means shell number 1. First shell have 2 electrons. 2s2, 2 means second shell. Second shell has again 2 electrons. But if you remember in grade 7, I told you that to complete the outermost shell, an atom must have 8 electrons. So this atom has 2 electrons and it needs 6 more electrons to complete this second shell. But to gain those 6 electrons is not possible because a very large amount of energy is required for this purpose, and that is not possible. So the easiest way to have complete outermost shell, this atom will lose these 2 electrons, and when it will lose 3 electrons, it will have only this one shell, and that is completely filled because first shell can accommodate 2 electrons. So this atom will have 2 electrons. So after losing these 2 electrons, and I told you that when an atom loses electron, it forms cation, and cation has plus charge. So this atom will get +2 charge because it loses 2 electrons. Plus, when an atom loses electron, so cation has positive charge. But if an atom loses 2 electrons, so then positive +2. Okay. So by losing 2 electrons, this atom will have +2 charge. +1 in the case when it loses 1 electron. +3 when loses 3 electron. -1 when gain 1 electron. But in this case, as I told you, it has 2 electrons in the outermost shell, and these 2 electrons must be removed to get stability. So for this purpose, this atom will lose 2 electrons and will get +2 oxidation state. Which term is same for 1 mole of oxygen and 1 mole of water? Molecules. Molecules are same for 1 mole of oxygen and 1 mole of water. Next one is about if 1 mole of carbon contains X atom, what is the number of atoms contained in 12 grams of magnesium? Number of moles of magnesium is equal to 12 grams and then divided by the molar mass, the same formula which you used before, how to find out the number of moles. So number of moles is equal to mass in grams over molar mass. Mass in grams are 12 and molar mass of magnesium is 24. So 12 over 24 gave us 0.5 moles. Okay, 1 mole contain how many atoms? X atoms. So 0.5 moles will contain how many atoms? Definitely 0.5. Got it? So correct option is, I forgot to encircle it, but this B is the correct option. Okay, 0.5x is the correct option. Now coming to what the short question answers. Number 1, differentiate between ion and free radical. We already discussed this topic before. In the topic, differentiate between ions and free radical. These are the atoms which bear some charge, mean positive or negative, anion or cation. And these are the atoms that have odd number of electrons. They exist in solution or in crystal lattice. Crystal lattice is just remember that this is the structure of crystal. Okay, lattice mean structure of crystal. You will learn inshallah in chapter number 4. 4 and in more detail in 5. They can exist in solution as well as in air. Their formation is not affected by sunlight, means sunlight is not compulsory for their formation, but the formation mostly they form in the presence of sunlight. Question number 2, what do you know about the corpuscular nature of matter? Again, I explain it in the Society of Technology and Science. Corpuscles means tiny particles, and an ancient Greek philosopher Empedocles thought that all materials are made up of 4 things. Those 4 things are named by Plato. He named them elements. And what are those 4 elements? Earth, water, fire, and air. Then Empedocles thought that these elements were influenced by 2 forces. Those 2 forces are attractive and repulsive forces. And we discussed it in detail in the topic. Number 3, differentiate between analytical chemistry and environmental chemistry. You can write it in by putting a line in between, and then at left and right side you can write, or you can write in this form, both are correct. The first, analytical chemistry, the branch of chemistry that deal with methods and instruments used for determining the composition of matter. It applies to quantitative analysis. Quantitative analysis means not only the quality. Quality means which atoms or which elements are present in that compound. That is called qualitative. But how many carbon, how many hydrogen, and how many oxygen atoms are there. That is, we have to find out the quantity. So that is called quantitative analysis. So in analytical chemistry, we apply quantitative analysis. We find out the percentage composition of compound. It means how much percent of each element are present. And I told you we use method for quantitative analysis, combustion analysis. Examples of analytical chemistry are melting point determination, boiling point determination. We do these experiments and then we find out the melting point and boiling point. So these are the examples of the analytical chemistry. Environmental chemistry, the branch of chemistry that deals with the pollutants and their adverse effects on human beings. It applies to qualitative analysis. Only we are analyzing the quality, like what are those pollutants, which causes the pollution, or which causes diseases in human beings or in plants or in animals. So over here we are not finding out the quantity, only we are finding out the qualitative analysis, like what are those compounds or what are those pollutants which pollute the environment and have effect on the living organisms. Example, acid rain, ozone depletion, these are environmental issues. Question number 4, what is mole? Mole, again, we explained or we studied in the previous lecture. Mole is an amount of substance that contains, these are the three definitions. It is a unit used to measure amount of substance. We abbreviated it as MOL, mole. It establishes link between mass of substance and number of particles. And these are the three definitions of mole. Already, all these things I explained in my previous lecture. Differentiate between empirical formula and molecular formula. There are four differences. The empirical formula for compound is the chemical formula that gives simplest whole ratio, and molecular formula gives us the actual whole ratio of all the atoms present in a compound. A formula which represents the simplest whole number ratio and it represents the actual whole number ratio. It is obtained from elemental analysis. I told you elemental analysis, combustion analysis, or we can call it quantitative analysis. And then by using the formula, empirical formula is equal to molecular formula over n, we can find out the empirical formula. And this one molecular formula we can get by multiplying n with empirical formula. How we find out the value of n? N is equal to molecular mass or empirical formula mass. When we will get n, then by multiplying this n with empirical formula, we can get the molecular formula. It is used for both molecular and ionic compound, and it is used for molecular compound only. All these things I already explained in the lecture. What is the number of molecules in 9 grams of steam? Grams are given, and we have to find out the number of molecules. So first thing, the formula of number of molecules is number of moles into Avogadro's number. We need moles. It means first we will use formula to find out the number of moles, mass over molar mass. So 9 gram, and steam is actually water. So molar mass of water is 18. 9 over 18 give us moles. Then we will multiply those moles by Avogadro's number. So answer is 3.011 into 10 power 23 molecules. Okay, so in this numerical you have to use two formulas. One formula for the number of moles, and then finally for the number of molecules. Just learn these two formulas, so this question is very easy for you to do. What are the molar masses of uranium-238 and uranium-235? You know that isotopes, they have same atomic number but different mass number. So this 238 and 235 is the mass number of uranium. So molar mass of uranium-238 is understood. Atomic mass of uranium-238 is 238 gram. And uranium-235 is 235 gram, the same, because these actually the name of the isotopes are on the basis of their mass number or their atomic number. Same like if we say for the carbon, carbon 12, carbon 13, carbon 14. So 12 is the atomic mass of carbon 12, 13 is the atomic mass of carbon 13, and 14 for carbon 14. So same. So uranium 238 is 238, but just you have to use grams, okay? Grams. Because molar mass, I told you, atomic mass, molecular mass, formula mass expressed in grams is called molar mass, okay? Why 1 mole of hydrogen molecule and 1 mole of hydrogen atoms have different masses? It's understood hydrogen molecule has 2 hydrogen atoms. And if we find out the molar mass, 1 plus 1 will give us the answer 2. And hydrogen atom is only 1 hydrogen atom, and the mass of 1 hydrogen atom is 1. This is the main difference. But if 1 mole of hydrogen, 1 mole of hydrogen atom or molecule, they have same number of atoms or molecules like Avogadro's number, but their masses are different. Okay. So 1 mole quantity of two different substances have different masses. For the same reason, the substances have different composition. H2 molecule H2 composition is it is made up of 2 hydrogen atoms, and this is only made up of hydrogen atoms. So composition is different. If we put 1 mole of hydrogen molecules and 1 mole of hydrogen atoms on separate balances, we would see a difference in mass, just as you do for the eggs and the limes. If you take 12 limes and if you take 12 eggs, and if you put it on balance, so definitely the limes will be heavier than the eggs. Although both numbers are same, but both are Avogadro's number. Both are 12, 12, but their masses are different. So this occurs because hydrogen molecule differ from hydrogen atom. Thus mass of Avogadro number of hydrogen molecule does not equal to the mass of Avogadro number of hydrogen atom. I told you example. Take a balance, keep 12 lemons or limes on one pan of the balance and 12 eggs on the second pan of the balance. You will see all the both are same number, but their masses are different. Got it? Question number 3, define ion, molecular ion, formula unit, free radical, atomic number, mass number, atomic mass units, all we done before, but only by writing the definition. We have to give example, for example, for anion, for cation, for molecular ion, for formula units, their example, free radical an example, atomic number, mass number, atomic mass unit, all these I already explained you, okay? So I'm just giving a quick review. Ion is a charged species formed from an atom or chemically bonded group of atoms by adding or removing electrons. Ions are formed when an atom gains or loses electrons. So there are two types of ions. Positively charged ions are called cation and negatively charged ions are called anions. For example, sodium after losing electron from cation, Na+, and calcium after losing 2 electrons from calcium, dipositive or divalent cation. Dipositive or divalent cation. The non-metal, usually they gain electrons and form anions. For example, chlorine atom gain 1 electron from Cl-, which is called monovalent, monovalent anion because it have only one negative charge. Oxygen is divalent because it has 2 negative charges. Then molecular ion, when a molecule loses or gain electron, then the resulting species is called a molecular ion. For example, O2 is a molecule and when it loses electron will form O2 plus cation of oxygen molecule. And if it gain electron, then anion of oxygen molecule. These ions are called molecular ions, and I told you they are also cation, molecular cations and molecular anions. N2 plus and N2 minus are also ions, and these are short-lived species and only exist at high temperature. Molecular ions do not form ionic compounds. Okay, keep this in your mind. Very important for MCQ's point of view that molecular ions they are not forming ionic compounds. Only the atomic ions they form ionic compounds. Okay, and short-lived means they form, but they are highly reactive, so they convert into stable compounds. Formula unit is the simplest formula of an ionic compound. simplest formula of an ionic compound. A formula unit, as the name implies, is one unit where atom, ion, or molecule correspond to given formula. As I told you, the sodium chloride, silica, they form giant structure, but we are not taking all the ions which are present in those giant structure. We just write a simple formula that all, if we see along y-axis, z-axis, or x-axis, all the ions, they are same, like they have sodium and chloride ions. So we will just write simplest formula or formula unit, that is sodium chloride, and we say it has one sodium ion and one chloride ion. So one formula unit, if we write for magnesium bromide, so you can see one magnesium and two bromide ions are there. Free radical. A free radical is an atom which has unpaired electron and bear no charge. You can see one electron, odd number, seven electrons, odd number. These are free radicals. Again, highly reactive, and they form in the presence of sunlight. And their molecules split up into free radical. Molecules split up. Cl2 molecule, when it split or breaks, will form two chlorine atoms. So each chlorine atom is then called free radical. Atomic number, the number of protons in the nucleus of an atom is known as its atomic number. Example, there is only one proton in the nucleus of hydrogen atom, therefore its atomic number is 1. Mass number is the total number of protons and neutrons present in an atom is known as mass number. Number of neutrons is equal to mass number minus atomic number. Atomic mass unit, again, one atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of carbon. Mass of carbon 12 is 12 AMU, and 1 AMU is equal to mass of 1 carbon divided by 12. Hydrogen atom is 8.40% massive than carbon 12, so we can find out its mass by 840% divided by 100 into mass of 1 carbon 12. 1.008 AMU. Similarly, radioatom mass of oxygen, sodium, aluminum are, oxygen is 15.99, which we mostly use 16. Sodium 22.9, so we use 23. Differentiate between ions and free radical. Again, I explained it before. This whole topic. These are the atoms which bear some charge. These are the atoms which have odd number of electrons. They exist in solution or ionic crystal lattice. They can exist in solution as well as in air. Their formation is not affected by sunlight, and they form in the presence of sunlight. Differentiate between molecular ion and free radical. Molecular ion, it is formed by gain or loss of electrons by a molecule and have even number of electrons, same like the atomic ions. It can have negative or positive charge, or it is a reactive species. Example are ammonium ion, which is molecular cation, and sulfate ion, molecular anion. Free radical, these are atoms or molecules that have odd number of electrons. These are the atoms or molecules which bear no charge, and they are highly reactive than iron. Okay, they are more reactive than molecular iron. Carbon trichloride and nitrogen are examples of free radical. Describe how Avogadro number is related to a mole. Again, I explained it before. For counting atom, molecule, and ion, we need a unit. That unit is called mole. Just as 1 dozen egg means 12 eggs, a rim of paper 500 paper, a pair of shoes are 2 shoes. Same like 1 mole of substances are equal to Avogadro's number of particles. For example, 1 mole carbon, Avogadro number of atoms, sulfur, Avogadro number of atoms, hydrogen is a molecule. So Avogadro number of molecules, water is a compound, Avogadro number of, and compounds are made up of molecules. So Avogadro number of molecules, sodium chloride is an ionic compound, so we will use Avogadro number of formula units. Number of moles related with Avogadro number is number of molecules over Avogadro's number. Hope you understand the lecture, dear students. Inshallah, the remaining questions we will discuss in the next lecture. Enjoy your Ramadan. Take care. Allah.